Hi everyone, it's Orkan. Today we have a problem when we need to design a maximum frequency stack. So what's that mean? So for example, let's say that we have a stack and we are pushing elements to the stack. So for example, let's say that the first we are pushing 5, we are pushing 7, we are pushing 5, 7, 4, and the 5. And when we are popping from our stack, normally when we are popping from our stack, so which means that when we are taking element from our stack, we are taking that the last element that we have added to the stack. But in this case, we need to return the element, most frequent element, not the last element that we have added. So for example, in this case, if we let's say that we are popping element, we are taking element from the stack, it will return us 5, right? But the next one will return us 7 because 7 is the most frequent element, right? So most frequent element that we have added to our stack. 4 in this case has frequency 1, but the 7 has the frequency of 2, so that's why we are returning 7. So how we're gonna solve this problem? Let's go step by step. By the way, this problem is very similar to the LFU cache problem. I have that in my channel, so you can check it out. So in the LFU cache, I in detail described what is our exact approach, and the approach is here exactly the same. So let's go step by step. First thing that we should do is we need to maintain a map where the key is our value, and the value is the frequency of that element. So for example, let's say we are pushing 5 3 times, right? So in our hash map we are maintaining a value 5, and how many times we have added that to what's the frequency of that element. So for example, 5 we have pushed 3 times, and the 7 we have pushed twice, and the 4 we have pushed once, right? So which means that the 4 we have added once. That's the frequency map. But besides the frequency map, we need to maintain something else. We need to maintain another map, where we are storing the frequency element and the order in which they have added. So for example, let's say that the frequency of 1, right? So first we are adding 5, so we are adding 5 to our stack. The next one we are adding 7, so it's a stack, so we are adding that to the top of the stack, right? So 7, and the next one is 5. So 5 now has the frequency of 2. 5 has the frequency of 2, so which means that we are not adding that to the first frequency. We are creating another frequency in the map 2, where we are adding 5, right? So we are adding 5, and again for 7 we are checking 7 already has the frequency of 1, so we are just adding 7, so which means that here we are increasing, so here we are adding that to the 2 frequency, right? So we are adding 7 to the 2 frequency. Again, we are adding that to the top of the stack, right? Because we are so it's a stack, so we need to 7 should be at the top. So the next one is that we are pushing 4. The 4 has the frequency of 1, so we are adding that here. So we are adding 4 that here. And the next one is that we are pushing 5, and the 5 now has the frequency of 5 has the frequency of 3, right? So it's repeated 3 times, so which means that we cannot add in any of these cases. We are creating a new frequency, new key 3, where we are adding 5, and now the 3 is our max frequency. That's another variable that we are maintaining, maximum frequency, where we are by maximum frequency we are finding our element, and we are returning that. So that's the whole solution. The solution is that we are creating 2 maps. The first map is where we are storing a key, and we are storing that how many times it's repeated, its frequency. And the next one is that we are creating another map where we are storing our frequency, and where we are storing that basically we are storing our stack, right? So for example, for the first we have added first 4, 7, and so we have added 5, we have added 7, we have added 4. For the frequency of 2, again another stack, which is that we have added 5 first, then we have added 7, and for 3 we have added only 5. So in this case, if we are popping, right, if we are taking, so which one we are going to take? So we are going to take 5 because this is the most frequent, our frequency, our max frequency in this case, right? Our max frequency is equals to, and we are keep updating that our max frequency is equals to 3. So we are taking so which element has the how many elements we have in our stack. In our stack we have only one element, 5, so that's why we are returning 5. We are returning 5, so we don't have any element with the maximum frequency of 3, which means that we are reducing our maximum frequency to 2. So the next element that when we are popping, we are taking 7, because with the 7 is the last element that we have added, so we are taking from our frequency map, and now we have 5 in our frequency map, right? So the next one is that we are again when we are calling a pop, which means that we are returning that the maximum frequency. We have only one element, 5, that we are returning. So now we have reduced to 1, right? So our now maximum frequency is equals to 1. Now next time we are calling pop, we are taking 4 from there, because that's the last element in the frequency of 1 that we have added. So that in the frequency of what that we have added. Solution wise, again, what we do is we are maintaining 2 variables. The first one is a frequency map, so where we are maintaining the key and value, the value that we are adding and the frequency of it. And in the next one, we are maintaining the frequency and the stack where we are adding elements, as we have seen here, right? So in the stack we are adding elements for that frequency. So what we do for the push, the first thing that we do when we are receiving an element and we need to push, we are checking its frequency, and we are increasing its frequency in the map. That's the first thing. Another one, we are updating in our map, we are updating that value with the new frequency, and now we are also updating our max frequency. If our current frequency is more than our max frequency, which means that we have a new frequency and we are updating our maximum frequency. If not, we're just keeping the old frequency. And the next one, that in our map, right, if we are checking that if it contains our new frequency, if it does not contain, then we are creating a new stack for it. If it already contains, then we are just pushing that to that stack. And in the pop, so what we do is, so when we are taking the element from the map, so when we are taking the element from our stack, so what we need to do, we are checking the max frequency that we need to return. If the max frequency is not there, so we are returning -1, right? If it's there, so we are taking the max frequency and we are taking the first element from the max frequency. And the first thing that we do, we are reducing the maximum frequency for that element. So we are, for that value, we are reducing that the frequency for that for that value. And the next one is that we are checking that if our maximum frequency is empty, for example, let's say we had only added 5 3 times, right? So if we are taking 5, then in that case, which means that we need to reduce our frequency. So we are decrementing our frequency and we are returning the value. And in case of the peak, so which means that we need to only check, we are just getting the maximum frequency and we are calling the peak of the stack, which returns us that element, which means that it does not remove it from the stack, it just returns us that element. So that's it. So for the time complexity wise, the time complexity of this solution is for the pop, for the push, pop, and the peak is of 1, it's a constant. And for the space complexity is, we are using here 2 maps, right? So we are using here 2 maps, and the worst case scenario, it's 2 of n, so we can disregard the 2 part, so constant part, and the space complexity is of n. That's it. I also have identical solution in Python, so I will include it in description. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.